Hi folks, this is finding the nth term of a quadratic sequence. So it's often referred to as t to the n, so you might see that in a question in an exam if they're asking for this. So our final answer is going to be given in this form. It'll be an squared plus bn plus c, and we have to figure out what the a, the b and the c are. So we're going to do that now, and then it's just putting them into that. So first thing we're going to do is we're going to find the second difference. So this is how we know that it's a quadratic sequence in the first place. So the difference between 8 and 17 is 9. The difference between 17 and 32 is 15. And then the difference between 32 and 53 is 21. So that's the difference between them. And then to get the second difference between them, the difference between 9 and 15 is 6, and the difference between 15 and 21 is 6 as well. So the second difference is the same, which is 6. So therefore it is definitely a quadratic sequence. So to get the a term, all we're going to do, and you have to remember this, is we're going to take the second difference, which is 6 in this case, and we're going to divide by 2. And we get 3 then. So you just have to remember that. So 3 is a basically. So a is equal to 3. So therefore our t to the n will be 3n squared plus bn plus c. So that's the a got. Now we have to figure out what the b and the c are. So the next thing I'm going to do is I'm going to take t1. So t1 stands for term 1, so the first term in the sequence. So if I was to put a 1 in instead of the n everywhere, I'd have 3 times 1 squared plus b times 1 plus c. And I know from looking at the sequence that the 8 is the first term in the sequence. So therefore all of that has to be equal to 8. And then if I take t2 and I just put a 2 in instead of the n everywhere, so sub in 2 for n, I have 3 times 2 squared minus b times 2 plus c. I should have had a minus there in the first one, actually I made a mistake. Plus c, so then, and now we know that the second term, so t2 is second term, so that has to be the 17, because that's the second term in the sequence. So I just let that equal to 17. Then I'm going to get two equations. So 3 times 1, I'm just going to simplify the first one now. So 1 squared is 1 times 3 is 3. So 3 minus b times 1 is b plus c is equal to 8. And then if I bring the 3 over to the other side, I get minus b plus c is equal to 3 goes over, becomes a minus 3, so 5. Now I'll go to the other one. So 2 squared is 4, and then times 3 is 12, so we get 12 minus 2b plus c is equal to 17. Then if I bring the 12 over to the other side, it becomes minus 12, so I get minus 2b plus c is equal to 5. So now I have two equations, and we have to use simultaneous equations then to solve them. So I'm taking this one and this one, and I'm just going to write one over the other. So we have minus b plus c is equal to 5, and minus 2b plus c is equal to 5 as well. So if I multiply the bottom one by minus 1, I'll get minus b plus c, so I'm just multiplying by minus 1 is equal to 5, and 2b. So whatever way you want to solve these now yourself. I always like to get the signs different in the middle. So have, for example, c and minus c, and then they cancel out like that, and I can just add all the terms then. But whatever way you've done it, so 2b minus b is b, and we get 5 minus 5 is 0. So we know that b is 0. So if I just take the very top equation in that there, so minus b plus c is equal to 5, so minus 0 plus c is equal to 5, so I know that c is equal to 5. So now I know what A is, what B is, and what C is, so I can just put them all back into the original. So T of n, we said, is equal to AN squared plus BN plus C. So our answer has to be given in that form, so therefore T of n is equal to, put in what the A, B, and C are, so 3n squared plus 0n plus 5, and I could leave out the 0n if I want, but that's our final answer then. So there's a lot in that. There's a good few steps. So here's one. If you want to try it yourself, you can, and then play it on. I'll go through the answers. So again, let's find our second difference. So difference between 4 and 7 is 3, difference between 7 and 12 is 5, and difference between 12 and 19 is 7. Then let's get our second difference. So of 3 and 5 it's 2, and of 5 and 7 it's also 2. So our second difference is the same each time. Now to get the A term, I'm just going to take whatever the second difference is, so it's 2 in this case, and I divide it in, or I cut it in half or divide it by 2. So therefore I'm getting 1 here. So our A is equal to 1. So I can put in, so T of n then is equal to 1 n squared plus bn plus c. Now 1 n squared is the same thing as n squared, so I don't even need to really put the 1 in there because n squared means 1 n squared anyway. But let's leave it in just to, so we don't get too confused. Now I'm going to take T1 then and T2, so we always do this. So we take T1, so I put a 1 in everywhere instead of the n, so it's 1 times 1 squared plus b times 1 plus c is equal to, and then that has to be equal to the first term in the sequence. So our first term here is the 4. So all that has to be equal to 4. So then we just get 1 there plus b plus c is equal to 4. And then bring the 1 over to the other side. B plus c is equal to 3. And that's our first one done. So we'll just take T2 then. So let's put a 2 in everywhere. So it's 1 times 2 squared plus b times 2 plus c. That has to be equal to our second term in the sequence, which is 7. We can look over there and see that it's 7. So then square that gives us 4 plus 2b is 2 times b is 2b plus c is equal to 7. Now let's bring the 4 to the other side and subtract it, and we'll get 3. So 2b plus c is equal to 3. So we've got two equations now, like before. Let's take the two of them and put one over the other. So if I change the signs of everything on the bottom, or multiply the bottom one by -1 there, or whatever way you want to solve them. So we get b is equal to 0. Then if I take the top equation, so our 2b plus c is equal to 3, and I put in a 0 instead of the b. Then I'm going to get that c is equal to 3. So we've got A, B, and C again. So it might necessarily always have one of them as 0. Here, the B is 0, so it makes the other bit very easy. And the same happened in the first example, but so it made it very easy. It won't always be like that, but it's only a matter of moving things to the other side anyway in the other equation. So if I sub a, b, and c into this then, so our a was 1, so I could put in a 1, or I could just leave it as n squared there, plus 0n, I could just leave that out altogether to 0n, and then plus 3 if I want. So I could actually give my answer as n squared plus 3, same thing.